Okay, so we're going to take a look now at the Chapter 6 review. It's on factoring polynomials. In this class, we don't do every technique of factoring, but we do 4 techniques of factoring. Hopefully you have your factoring flowchart. If you don't, it's available under handouts to print, I think. When you're going to factor a polynomial, you have to almost have this questioning going on in your brain. First you ask, is there a common factor? And if the answer is yes, you factor out the greatest common factor. That might be step 1 of 2, or it might be the only step. Whether that works for you or not, then you go on based on the number of terms that are in the polynomial. 4 terms, grouping. 3 terms, trial and error. We didn't really spend any time in here discussing perfect square trinomials. 2 terms, difference of squares. There are some more branches down here that have to do with cubes, but we don't do those in elementary algebra. So as we work through the review, I'm going to use this questioning, and I'll probably come back to this screen. All right, hopefully you have your own copy. And if I need some blank paper, then I will get the blank paper electronically. All right, for each one of these problems, I'm going to go through and say exactly what my brain is, what I ask myself, because that's what you need to do. All right, problem number 1. The instructions say factor completely. I have z squared minus 12z plus 36. Question 1, is there a common factor? No. Okay, no common factor. Second question, how many terms are there? There are 3. So I'm going to use trial and error. Okay, that was the technique we learned last. The trial and error, I'm going to have 2 sets of parentheses. Let me make those a little bit bigger. And we'll talk about the signs. The signs have become a little fuzzy in this projection, but hopefully you see on your paper that this is a plus and this is a minus. The plus on the 36 tells you that the 2 signs in the factors both match what? The negative of the middle term. So I'll put a minus and a minus. I will go ahead and put in this case, letter Z in both of those. Now, I need factors of 36. They need to multiply together to be 36, then they need to add together to be 12. So to get a 36, I have 1 times 36, but those don't add to be 12. 2 goes in there 18 times. Those don't add to be 12. 3 goes in there 12 times. Those don't add. 4 goes in there 9 times. That's 13, but still not right. And then 6 times 6. You probably thought 6 times 6 a long time ago, and that's great. And you don't need to make a list when you come up with the factors right away. So I'll put in the 6 and the 6. Just to keep the clutter off of this, now I'm going to erase these. I hope you'll check. You wrote down the answer and you go, let me check it. I will check it by using multiplication, in this case FOIL. The product of the first, z times z, is z squared. The outer product is negative 6z. The inner product, negative 6z. Combine them for negative 12z. Negative 6 times negative 6 is positive 36. Are we good? Okay, and those are all the questions that I think of and answer for myself. Let's go to the second one. All right, number 2. Let me see, I can make that a little bit bigger. It might get a little fuzzy, but you've got your own printed copy, I hope. All right, is there a common factor to all the terms in number 2? Okay, you look and at first you might think, well, yeah, I think they all have 6. Nope, only some of them do. 11? No, only some of them do. Why? No, only some of them do. The answer is no, there's not a common factor. Second thing, how many terms do you have? 4. Automatically grouping. If I went back to this, I'm down here to grouping. 4 terms, grouping. All right, so let's see. First group, second group. What's in common in the first group? 6, okay? So if I factor out a 6, 6 goes into 6x, x times. 6 goes into 66, 11 times. So I have 6 parentheses, x plus 11. Is this too tiny for y'all to see? I think this is smaller than I usually write. Let me see if I can make it larger. Whoops. Second group, remember to always bring down the sign that's between them. What's in common in the second group? Y, okay. And if you factor out a y, by the way, if you need to write the y under there, if you need to write the 6 under there, that might help. In the first one, xy divided by y leaves you with x, and 11y divided by y gives you 11. If you're doing it right, you see a common binomial factor. Factor it out as x plus 11, and what's the other factor? 6 plus y. And it's gotten a little bit crowded, but is that okay? You can check it with FOIL. The terms won't necessarily come in exactly this order, but let's take a look at this. X times 6 is 6x. Yep, it's there. Outer product, x times y is xy. It's over there. Inner product, 11 times 6 is 66. It's right there. And last, 11 times y is 11y. There aren't any like terms, so the outers and inners don't combine. You do get all 4 terms, checking it with FOIL. Is that okay? All right. You know, I think it might be better for us to, whoops. Put my work here. Hopefully you've got your copy. If you don't have your copy, in class, it's over there, sitting by the roll sheet. And if you're working from home, there is a copy under review for tests. So let's go to number 3. I just think this may be a little bit better with more room. I have 2x squared minus 16x plus 30. What's question number 1? Greatest common factor. Is there one? Well, does 16 go into all of them? That's what your question has to be. Can you think of something that goes into all of them? 2. They're all even. All the coefficients are even. 2 is a common factor. So if I factor out the 2, that means I'm dividing everything by 2. That leaves me with x squared minus 8x plus 15 in the parentheses. Is that okay? Now, that may be all I can do, but look at the trinomial factor. Does that look like something that we've worked on? Yes, that's the kind of trinomial we factored. It's very important that you keep the 2. And then let's see if we can factor this trinomial by our trial and error. The signs. The last sign is positive. What does that tell you the signs are? Both negative. I need an x and an x. I need factors of 15 that add up to be 8. Is it 1 times 15? Nope. 2 doesn't go in there. Is it 3 times 5? Yes. Now, to check this, to check these factors, use FOIL. X times x is x squared. Outer product, negative 5x. Inner product, negative 3x. Those add up to be negative 8x. Negative 3 times negative 5 is positive 15. To check the greatest common factor, you'll use the distributive property. 2 times x squared is 2x squared. 2 times negative 8x is negative 16x. And 2 times 15 is 30. So a two-step problem takes 2 steps to check. Is that okay? All right, let's look at number 4. I have x squared minus 49. Is there a... Oh, sorry. I do like to make up my own letters. On a written test, I wouldn't penalize you for something like that, but my math lab won't tolerate it. So, is there a common factor? No, there's just 2 terms and there's nothing in common. Ah, it is 2 terms. We only know one kind of binomial that we have the skills to factor. It's the difference of squares. Is this a difference? Yes, because that's a minus sign. Is z squared a square? Yes. Is 49 a square? Yes. So if all of those are yes, then this factors into a sum and a difference. By the way, that works with our sign patterns because the last sign is negative. That always tells you it's one of each. All right. Square root of z squared is z. Square root of 49 is 7. Check it first. Z times z is z squared. Outer is negative 7z. Inner is positive 7z. Those cancel. No middle term. Product of the last, positive times negative, is negative 49. Difference of squares. Number 5 is x squared minus 7x plus 10. Is there a common factor? No. Okay, but how many terms? 3, trinomial, trial and error. So here we go with the parentheses. This seems to be the third one that's been like this. The last sign is positive. What are the 2 signs? Both negative. X and X. I need factors of 10 that add up to be 7. 5 and 2. It doesn't matter whether you put the 2 first, the 5 first. It doesn't matter because their signs are the same. My choices were 1 and 10 and 2 and 5. And 2 and 5 worked. Is that okay? Number 6. I have x squared minus x minus 48. Is there a common factor? No. 3 terms, trinomial, trial and error. Tell me about the signs in this one. Positive and negative. When the last sign is negative, it doesn't matter about anything else, you've got 1 plus and 1 minus. Okay, I know I've got an x and an x. Please be cautious. When you use the plus and minus, it means that you're going to look for a difference of the outers and inners, not a sum. The difference needs to be negative 1. Okay, so I'm looking for factors of 48 with a difference of 1. So 1 and 48, no. 2 goes in there 24 times, and that's no. 3 goes in there 16 times, no. 4 goes in there 12 times. You might be using a calculator to get these paired. 5 doesn't go in there, 6 does, 6 times 8 is 48, and that's it. Do any of these work to give you a difference of 1? No. So what do you say about this polynomial? It's prime. Okay, and I will tell you prior to the test how many primes you'll have. I believe there are 3. I think there are 3. Oops. Number 7. I have 5x to the 6th minus 25 x squared, oops, no, x to the 5th minus 120 x to the 4th. Is there a common factor?
Yes.
Yes. 5 goes into all of them, and what else?
X.
There's x in all of them. What power of x can I take out? The 4th. The lowest one. That's our rule. If there's x in all of them, you can take no more than the lowest power. So my greatest common factor is 5x to the 4th. When it's kind of complicated like this, I recommend doing this little division. Some people don't need it, some people do need it. 5 goes into 5 one time. I don't write coefficients of 1. If I have x to the 6th over x to the 4th, what do I do with the exponents? Subtract them. So I have x to the 2nd minus 5 goes into 25 5 times. X to the 5th over x to the 4th is x to the implied first minus 5 goes into 120, how many times? 24 times, and the x to the 4ths divide out. So there we go. Is everybody good with the greatest common factor? That made the problem look a lot different when I took that out. Now, sometimes when we started this unit on factoring in section 6.1, we found this greatest common factor and the problem was finished. But we've learned more since then. The trinomial that you see here, does it look like something you are accustomed to factoring?
Yes.
So let's try. Don't lose this 5x to the 4th. It is a factor, it just doesn't play a role anymore. Okay, signs. Tell me about the signs. Okay, good. One positive, one negative. That comes from the last sign is negative. That means the factors are always 1 plus and 1 minus. And I'll sneak in my x's. I need factors that, because the signs are different, have a difference of 5. So 1 and 24 do not have a difference of 5. 2 times 12 does not give you a difference of 5. 3 goes in there 8 times? Yes. Do you agree that 8 minus 3 is 5? Okay, now there are other things. There's also 4 and 6. But we found the pair right here. You have to be careful. When there's 1 plus and 1 minus, you're looking for a difference. Now, does it matter where you put them?
Yes.
Okay, when they're the same sign, it doesn't matter. But when the signs are different, it matters. The bigger number, in this case the 8, gets the sign of the middle term. So I put in the 8 there and the 3 there. But here's what you always need to do. Always check your outer and inner products. And that's negative 8x, and that's positive 3x, and that gives me negative 5x. If it gave me positive 5x, I would either switch the numbers or switch the signs. Remember that you have to write all of this down to have the factors. Is that okay? Let's look at number 8. I have x squared minus x minus 54. Is there a common factor? No, not in this one. It's a trinomial. We've been having a lot of trinomials. They seem to dominate the test. Well, there will be some more kinds showing up, but yeah, this is a big deal. Tell me about the signs. Plus and negative. Okay, put in my x and x. The two numbers that I choose to go in these last spots, what two things do they have to do? Okay, they've got to have a difference of -1, and they've got to multiply together to give me 54. Okay, so here we go. It's not 1 times 54. 2 goes in there 27 times, and it's not right. 3 goes in there 18 times, and that's not right. 4 doesn't go in evenly. 5 doesn't go in there evenly. 6 does. 6 times 9, but that has a difference of 3. 7 doesn't. 8 doesn't. I'm back to 9. I have all the factors. Do any of them give me the middle term? So what do you say? Prime. Now, please do not think that every time there's a 1, it's prime, or that all primes have 1s. That's just the way a couple of problems have been for us. Okay, number 9. I have 3x to the 4th plus 24x to the 3rd plus 21x squared. Is there a common factor?
Yes.
Okay, it's
3x
3x squared. Okay, all the numbers are divisible by 3. All the terms have x's. I take the low power. It's 3x to the 2nd. And once again, sometimes on these, I think it's very worthwhile to write that under there. What do I get for the first quotient? X squared. Good. I use the quotient rule, which told me to subtract the exponents, the 3's divided out. Plus 8x plus 7. Good. I might be finished, but in this problem, I'm not. All right, take a look at this trinomial. Does this look like something we've factored? Yeah, so let's keep the 3x squared and try to factor the trinomial. Tell me about the signs. Positive, positive. There's an x and an x. Well, 7 is a prime number. The nice thing about that is that I only have one choice. It's 1 and 7. Do 1 and 7 add up to be 8? Yes. And you notice I have gotten a little lax on checking these. I would not be lax on checking these if this were my test paper. I would multiply these by FOIL. Once I got that, then I would distribute to see if I got that. Is that okay? All right, let's look at 10. I have x squared plus 107x plus 108. Is there a common factor? No. No. So I go into trial and error. Tell me about the signs. Both positive. Of x and x. All right, factors of 108. Well, I may definitely need a calculator for this, but let's see. 1 and 108 do not add up to be 107. Now, if it had just been a plus and a minus, I'd be in good shape, but it's not. It's 2 pluses. All right, 2 goes in there 54 times. Those don't add up to be 107. Does 3 go in there? Yes, it does. 3 goes in there 36 times. Does it look like I'm headed towards something that's going to add up to be 107? No. This factor is going to get a little bigger. This factor is going to get a little smaller. It's not going to get close to being 107. I can keep going. 4 goes in there. Whoops. See what I mean about sometimes I make things jump. 4 goes in there 27 times. And you can see it's really just getting worse. It's not getting anywhere close to 107. So is it okay if I stop?
Yes.
What do we say?
Prime.
It's prime. You want to be careful. Honestly, if this were a test question, I might not stop. I would have a calculator handy and I would say, well, let's see, 5 doesn't go in there. Does 6 go in there? Yeah, it does. 6 goes in there 18 times. Still's not working. 7 doesn't go in there evenly. 8, no. 9, yes. 9 goes in there 12 times. And finally, I've gotten all my factors. And I didn't get any closer to getting 107 as I move through those. It is indeed prime. But you don't know it's prime unless you actually thought through all the possible combinations. So I don't want to encourage you to say prime too soon. Number 11. I have 81 k squared minus 100 m squared. And we're back. All right, is there a common factor? No. Look at the numbers, play with 81 and 100, but no. It's a binomial. What kind of binomial do we know how to factor? We only know one kind. Difference of squares. There it is. When you have a square minus a square, and this is just an example, it factors into the sum and difference product. So this is the difference of two squares. 81's a perfect square, k squared. A difference, 100's a perfect square, m squared, a perfect square. So here we go. 1 plus, 1 minus. What's the square roots of 81? Or what is the square root of 81? 9. So I need 9k. Square root of 100? 10. And it is very common to leave off the letters. You get so caught up in the numbers that you don't focus on the letters, but please do. Product of the first is 81k squared. The outer is negative 90 km, but the inner is positive 90 km. Those cancel. Product of the last, negative 100 m squared. I hope you'll find difference of squares to be the easiest. Number 12. I have x squared minus x minus 35. Is there a common factor? No common factor. It's a trinomial, so it's trial and error. Tell me about the signs. Plus and minus. I have x and x. Factors of 35. 1 and 35, that's not working. 5 and 7, that's not working. It's a difference of 2. Any other choices? No. So it's prime. I don't know how many primes we've come up with so far on this. That's 4 on the review. Okay, but I believe there are only 3 on the test. I'll double check it before I hand them out and announce it. There are 4 here. All right, number 13. I have 5x plus 60 plus xy plus 12y. Any common factor to all four terms? No. There's certainly some common things going on, but not to all the terms. But I did say four terms. What technique do we use with four terms? Grouping. So first group, second group. Looking just at the first group, what's in common? A 5. And write it under there if you want to. That'll give me x plus a 12. Bring down your plus sign. What's in common in the second group? Y. And when you divide it, you get another x plus 12. Now that is absolutely a requirement. If grouping's going to work, those two have to be identical. That's a common binomial factor. I factor it out, x plus 12, and what's my other factor? 5 plus y. You check it with FOIL and it will regenerate those four terms, but not necessarily in the order they're listed. Is that okay? All right, let's look at 14. I have z squared minus 4. Is there a common factor? No, it's a binomial. Is it the kind of binomial you know how to factor? Okay, somebody says yes. What kind is it? Difference of squares. That's really got to be present in your mind. It is a difference, a minus sign. That's a square, and 4 is a perfect square. When it is the difference of squares, it factors into the sum and the difference of their square roots. So z plus 2 and z minus 2. I always put the plus in the minus, but that is by no means a requirement. Number 15, z squared minus 121. Is there a common factor? Okay, if there is, what is it? No, there's not a common factor. So, what kind of a polynomial is it? It's the difference of two squares. Difference minus sign, square minus square. So, what are the signs always on these? Plus and minus. Square root of z squared is z. And the square root of 121, 11. If perchance there is a number here and you think, well, if I'm going to be able to factor this, that needs to be a perfect square, test it with your calculator if you're not sure. Number 16. 9k squared minus 49m squared. Is there a common factor? Okay, what is it? All right, you see the 9 there, and so visually you may think that, but 9 doesn't go into 49 evenly. Okay, so visually you're tempted to say that, but there is not a common factor. Is it the kind of binomial you know how to factor? Which is what? Difference of squares. And I'm sorry, it turned out there's like 3 or 4 in a row on the review, but don't expect that on the test. I definitely did some scrambling. So I have a plus and a minus. What's the square root of 9k squared? 3k. And what's the square root of 49m squared? 7m. So I have 1 plus, 1 minus. I have the sum and the difference of their square roots. Okay, let's look at 17. I have x squared minus 3x minus 40. Okay, is there a common factor? No? All right, then I will see it as a trinomial, put down my parentheses, tell me about the signs. Plus and minus. Need an x and an x. I'm going to need factors of 40. What do those factors have to do? Okay, they have to equal to minus 3. Will they equal to minus 3 if I add them or subtract them? Subtract them because the signs are different. So 1 times 40, nope. 2 times 20, nope. 3 doesn't go in there. 4 times 10, nope. 5 times 8, bingo, got it. Now, does it matter where the numbers go? Yes. Now, I'm just going to throw them in there. Don't write it down yet. Maybe I didn't think about where I ought to put them, and I just threw them in some spots. And then I check, and my outer product is negative 5x, and my inner product is positive 8x, which gives me a middle term of positive 3. But I was supposed to have negative 3. If I do that, I either change the position of the numbers, or I could just change the signs. And now it works quickly. No. When I have a plus and minus, old habits, I always write the plus first and the minus second. But in the end, if I realize I've done something wrong, I may move them. All right, let's look at 18. I have 6 m to the 9th plus 18 m to the 6th plus 30 m squared. What's question number 1? Is there a common factor? And can you think of something that goes into 6, 18, and 30? Okay, you were right when you said 3, but it's not the greatest common factor. My question was just, can you think of a number? So the answer to that question, 3, would have been okay. What I should have said is, if there's a common factor, what's the greatest one? And the answer is 6. For the numbers, how about variables? Okay, they all have an m. What power of m can I take out? Squared. I can take no more than the lowest power, and definitely don't want to take less than that. So I want to divide 6m squared into each one of these. All right, if you divide the first quotient, the 6's divide out. What's m to the 9th over m to the 2nd? M to the 7th. Okay, 6 goes into 18 3 times. I have m to the 6th over m to the 2nd, which is m to the 4th. And then 6 goes into 30 5 times. The m squareds divide out. So I've done that. Now, when I factor out a common factor, I need to always look at the new factor that I've created to see, can I do more? Now we know how to work with trinomials, but take a look at this trinomial. An m to the 7th, dropping down to an m to the 4th, and then to a constant. Have we factored anything like that? The answer is no. Our patterns have been things like m squared plus 3m plus 5. Not that that's factorable, but that's at least been our pattern. Or we've had, say, m squared plus 3mn plus 5m squared. Those are the only two kinds of trinomial patterns that we've been able to attack. Look at the patterns on the exponents. So have we done anything that had a m to the 7th? And if you started working on it, how would you break up m to the 7th? It's not even an even exponent. So guess what? We're done. It's not prime. We factored it. We factored out the greatest common factor. This could have been a problem from section 6.1, where all we were doing was looking for common factors. You have so many more skills now, but that is not factorable any further. You're done. Okay, let's look at 19. Oh, 19, I believe we're supposed to omit. Didn't I highlight that in class the other day? So I apologize for that problem. I'll mention something about it. I double checked the test to make sure that it was not on there, or something like it wasn't on there. And the reason, there's no common factor here, which means that's staying at 25x squared. And we didn't do problems where the leading coefficient was anything other than a 1. This is factorable, but we didn't focus on this, and I shouldn't have let it slip in there. This, and I will just share with you, the signs we know. The last sign's positive, this one's negative, so they're both negative. So 5x times 5x gives me 25x squared. 64y squared. Well, there's a lot of combinations, but I'm going to go 8y and 8y. And now I've got to check it. What's the outer product? Minus 40xy. What's the inner product? Minus 40, oh, hello, xy. Do those combine to be negative 80xy? Yes, those are the factors, but it's an inappropriate problem considering what we studied. Okay, so good for you. Not on the test. Number 20. I have x squared. No. I have z squared plus 10z plus 25. Is there a common factor? No. When the leading coefficient is a 1, that means there's not going to be a numerical, a number common factor. And when the last term doesn't have a z, there can't be a variable common factor. So it's a no. It's a trinomial, so here we go. We'll try. Tell me about the signs. Did I say something funny? Oh, okay, it was a little pun. All right. Z times z gives me z squared. What are the factors of 25 that add up to be 10? 5 and 5. I tried the trinomial, and we got it right. You might sometimes see the answer as x plus 5 squared. Not necessary at all, but sometimes you would see that written. Yes, ma'am?
What I just did, I wrote the x and then it's z.
That is just a very bad habit.
Yep.
I am conditioned just like y'all are conditioned to use x most often. And on a piece of paper, I'm not going to count that wrong. But if you're taking a computerized test, it would count it wrong. So, sorry, I am guilty of that as well. So, going back to the flow chart. Right, I'm chopping off part of it, but it's an irrelevant part for us. Always ask yourself, is there a common factor? What's the greatest common factor? Factor it out. That may be your only step, but you may create something you can factor further. If it's 4 terms, grouping. If it's 3 terms, trial and error is all we focused on. If you take intermediate algebra, you will focus on perfect square trinomials also. If it's a binomial, the only thing we focused on was difference of squares. In intermediate, you look at some cube patterns. Okay, I will address that.